Alright, let's look at the useful limits of trig functions. Right, first one is limit of sine of theta over theta as theta goes to 0 is equal to 1. And the second one is a limit of cosine of theta minus 1 over, I messed that up, over theta as theta approaches 0 is equal to 0. Right? So let's prove both of these guys. Right? So here, we notice that here, sine theta is an odd function, and theta is an odd function. Odd function divided by odd function is an even function. So this is an even function, and when you have an even function, the graph is going to be symmetric about the y-axis. So you have exactly the same thing going on, mirror image going on the right-hand side and the left-hand side of the y-axis. All right, so it suffices to show that the limit, right-hand limit, is going to be equal to, I missed this one up again, is equal to 1. If the right-hand limit is equal to 1, left-hand limit is automatically the same because there's a mirror image on the other side, right? So let's try to show that, right? So I'm going to draw a unit circle, and say this angle here is, say, theta, right? Then what you want to do is we want to find sine theta. So you can see that the sine theta shows up as the y coordinate of the point on the unit circle, if you remember when you do a unit circle. So this length right here is a sine of theta, right? And the length of this arc right here, so this piece of arc is going to be, the radius, which is 1, because it's a unit circle, times the angle in radians, which is theta. So the length here is going to be theta, right? And here, if you extend this and then find the intersection with the vertical line here, then this length is can be represented by tangent of theta. All right, then you can see that if you can accept the ordering, you can see that the sine of theta is shorter than theta, and then theta is shorter than tangent of theta, right? So we have this inequality. So we have a sine of theta is the shortest, right? And the theta is the middle guy. And then we have a tangent, which I'm going to write it as a sine of theta over theta. Right? All right. Oh, not theta. Sorry, cosine of theta, because it's tangent, right? So, right. So we have that. So this is tangent of theta. All right. So what I'm going to do is first I'm going to pick on this first inequality here, right? And from the first inequality, this is what we can get. So 1, right, this is going to give us this. Right, I'm going to divide through by theta. So you have a sine of theta over theta is going to be less than or equal to 1. Right, so we got the 1 inequality. Right, so let's look at the second inequality here. Right, so the second inequality. So take the second inequality, and what I'm going to do is I'm going to actually divide by sine of theta. Right, so theta divided by sine of theta, so theta divided by sine of theta, and is less than or equal to 1 over cosine of theta. Right. And then I'm going to actually here take the reciprocal of both sides. All right. So you have a sine of theta over theta, and reciprocal cosine is just a cosine of theta. right? When you take the reciprocal of positive numbers, the order switches, so it's going to be greater than or equal to that. All right, by combining these two inequalities, we get this. So sine of theta over theta is going to be less than or equal to 1, and also greater than cosine of theta, right? Then if you want to find the limit of sine of theta cosine theta, I'm going to use the squeeze theorem, right? So let's look at the limit of cosine of theta as theta approaches 0, right? From the positive side, right? Cosine of 0 is 1, so this is going to be 1, right? And the limit of the biggest guy, which is actually a constant function, theta approaches 0 from the positive side, constant still be the same constant, right? From here, we can use squeeze theorem, right? Largest guy and the larger guy and the smaller guy both go to 0, so middle guy has to go to the same place. So you have a limit, and sine of theta over theta, as theta approaches 0 from the positive side, is going to be equal to 1. It's got to be the same. So this is by squeeze theorem from calculus 1. All right, so therefore we have the right-hand limit equaling 1, and we can use the symmetry of an even function and to show that so this is limit, and the left-hand limit is obviously going to be 1 as well, because you have a mirror image on both sides of the y-axis. Right, so therefore, combining the right-hand limit and the left-hand limit both equaling 1, which means that the regular both-sided limit is equal to 1. So that verifies this first limit. All right, let's prove the second limit too. All right, so it actually comes from the first one. So here's a proof. All right, so what we want to do is I'm going to do this. So limit the theta approaches 0. All right, somehow we have to get the first guy involved. And the easy way to get the sign is this, using a trig identity. All right, so we know that, let's see, we can do, say, cosine squared of theta minus 1 is same thing as a negative sine squared of theta, right? So what we can do is I'm going to multiply top and bottom by cosine of theta plus 1 and a cosine of theta plus 1, right? So if you do that, you're going to get this. So this is going to become limit theta goes to 0. All right, top one, you're going to have cosine squared of theta minus 1, right? Then on the bottom, there's not much you can do. It's a theta times cosine of theta plus 1, right? But on top, this is exactly the same thing as negative sine squared of theta, right? Then we can just rewrite it this way. So you have a limit as theta approaches 0, right? So here's what I'm going to do. I'm going to use one of the sign here. I'm going to put it here, right? So that takes care of one of the sign, right? And then I'm going to use theta because I want to pair it up with sine of theta, right? And then what's left is you're going to have a negative sine of theta, and you have a cosine of theta plus 1, right? So from the first limit, we know that this guy right here, sine of theta over cosine over theta, so this guy goes to 1, right? For the second part here, sine of 0 is 0, so this guy goes to 0. and the cosine of 0 is 1. This guy goes to 1. So it's going to be 0 over 2, which is a long way of saying 0, times 1. 0 times 1 is 0. So we know that the limit is equal to 0. Right? So which verifies this second limit. Right? So those two limits are very useful when it comes to deriving the derivative of a trig function. So keep these guys in mind. All right, that's it. I hope that this was clear.